Okay, here we have another example. Once again, it is a direct variation. Remember that what a direct variation is. It's our linear relationship. It's proportional. It's constant. And we've said, once again, we can represent it by this idea of y over x equaling that slope or that constant. And that equation can be rewritten as y equals mx. So if we see an equation that looks like y equals mx, this m, which is in front of the x, what do you call a number in front of a variable? Say it again, a coefficient. So we can start identifying the coefficient and realizing, hey, that's the slope. But we'll get there in a little bit. In this situation, we have a cyclist. He can go 3 miles in a quarter of an hour. Okay? So probably the miles he goes depends on how long. It says here, the distance biked in miles, y. Okay, so y is his distance, and x is the time. So what have I told you so far with direct variation? You can simply do y divided by x, and you can get your slope or your unit rate. So I can take 3, divide it by 0.25, and I get 12. So just like that, I've discovered what my slope is, or my coefficient, my constant rate of change is 12, which in a direct variation is the same as unit rate. So in this situation, a unit rate, 12, that means he can do 12 miles every hour, 12 miles an hour on his bike. Now, don't forget to pay attention to what the question asked for. It said to graph an equation. Well, did they give us an equation? No. We have to come up with it. Okay? Well, the nice thing is we have just figured out what our slope is, and we know that our slope is equal to m. So we can write an equation very easily by saying y equals 12x. Y equals 12x. So now we have an equation. Then they said graph this equation. Graph the equation. Now, how do you graph an equation? How do we have a graph equation?
Don't you take what, like 12 and 12?
12 is going to be involved. But what do we need to do in order to graph something? We need points on that graph. What do we call those points? Coordinate pairs. Everybody say coordinate pairs. So how do I come up with coordinate pairs? How many people remember like an input-output function from last year? All right, so check this out. Eyes right here, Trevor. Oh, you just made the video. If I've got y equals 12x, I'm going to use an input. I'm going to use that as my input-output function and create a table. So let's say the nice thing about input-output, you're in charge of what goes in. You just have to come up with it. And this is what they did over here. They said, we're going to use 0, 1, and 2. When I put 0 in for x, what do I end up with? 0 times 12 is? 12. 0. When I put 1 in for x, what's 1 times 12? 12. When I put 2 in for x, what's 2 times 12? And guess what I've just developed for myself? 3 coordinate pairs. Now I can plot them on the graph, the point 0, 0, the point 1, 12, and the point 2, 24, and I've been able to graph my line. Okay? All right, another way that we can graph it, we'll get there soon, is if you know the slope and you know one point on the line, right? We know the point, we know in this case the slope is 12, all right? Another way to write 12 is 12 over 1, right? So if we know this goes through 0, we can go up 12 and over 1. We can do rise over run, and we can graph things that way too. So there's lots of options. But in this problem, it's important to remember to take the y value, to take the x value, divide them to get your slope, which was 12. All right, let's look at one more example. All right, here's another example where this problem was talking about some bamboo. And we've got some kind of bamboo that can grow ultra fast, okay? And we want to know how fast can this bamboo grow in 1 hour. Okay? How fast can it grow in 1 hour? All right? Well, it tells us that it can grow 7 inches. It can grow 7 inches in 3.5 hours. Okay? How do I determine how fast it can grow in 1 hour? What do you think, Cedric? All right, 7 divided by 3.5. All right, so what is that? Isn't it 2? Okay, so we've got this kind of bamboo that can grow 2 inches every hour. That's crazy. Okay, that's crazy fast. Now, what does this look like that you just did? This looks a whole lot like y over x equals m. That's what you just did. And then if we were to graph that, okay, we could do the same thing, but we know that after 1 hour it grows 2 inches. We know after 3 hours, what was it, 7 inches or something like that. And we can start to plot these points, and then we're able to graph them on a line. Okay, you have a got it problem at the bottom of page 190. Got it B. Go ahead and attempt that problem, please.